Hi, and thank you for joining today. So containers are the future, but that doesn't mean that virtual machines are going away. So the question really is, what's the best way to manage VMs and containers at the same time? You're most likely here because you're interested in virtualization or because you're curious about how to run VMs on Kubernetes. If I tell you virtualization, I'm sure that the first thing that you will think of is VMware, but that's not the only solution. My name is Romain Decker, and I'm a principal product manager working at Spectro Cloud. I have a long experience in virtualization. I started working with virtualization 20 years ago in 2003, and I spent almost 9 years at VMware. So I've designed, deployed, and managed small to large scale infrastructure, virtualization infrastructure for small or large organizations. In terms of agenda, first, I would like to make a short poll so that we can have some ideas. So the poll will appear in a moment, but in terms of agenda, I will start with the current state of cloud native applications and why VMs still have a role to play in your infrastructure. Then I will get into what KubeVirt is and how it can help the world of cloud native applications. But I will also discuss about the challenges that KubeVirt bring. Finally, I will present our new Virtual Machine Orchestrator capability from Spectro Cloud Palette and how to use it to bring VM capabilities into Kubernetes. By the end of the webinar, you will have a better understanding on how to have your VM and your containers managed together. In terms of housekeeping, we can keep this interactive. In the platform, you have a question mark icon where you can ask your questions, and I will monitor this section, and I will stop at the various sections and answer you. We will be recording, so this webinar is recorded, and the recording will be shared afterwards. So the first poll should be displayed now. Let me move on. So the current state and challenges. So let's get back in the future. So software is changing traditional business models and industries. Software is eating the world, and everyone knows that. Cloud native applications change the software landscape. The frequency of deployment is changing, and the average size of the change of the deployment is decreasing. But this shift didn't come only with benefits, it also brings new challenges. So in that small diagrams, I haven't represented mainframe, but basically we came from mainframe, client server, bare metal servers, virtual machines. Then we had containers. Then we had to find a way on how to manage containers at scale. That's Kubernetes. We also have serverless, function as a service, you name it. So it looks like we're seeing a nice linear modernizations from VMs to containers with accompanying trends such as like more applications, smaller microservices, faster release cycle, and so on. However, although we have seen these massive adoptions in terms of container-based workload, VMs are here to stay, and that's the reality. For most organizations, refactoring all their applications is almost impossible. It's a significant amount of effort. Even today, if you look at numbers, there is an estimation that 85 to 90 million enterprise workloads are running on VMware vSphere. And that number is only going to grow over the next few years. At the same time, there are many organizations expressing concerns about the VMware acquisition by Broadcom. However, I think that the main driver is the need to modernize the IT infrastructure. And one way to do that is the ability to manage VM and containers at the same time. So we run some questions and some polls through our customers and through some various reports that we have. And those are common challenges that we see in the landscape. So we have customers that want to manage their existing applications hosted on VMs, but it also means that they are struggling to manage both platforms. So a platform for containers, a platform for VMs. And it means that they have different platforms in terms of hardware, in terms of networking, in terms of people most of the time, because it's not the same person that manage both platforms. They have different security policies, different role-based access control, and so on. Other customers also have a long-term strategic plan to move to containers, but they also need an interim solution that will help us as they will gradually refactor their applications. Sometimes also customers have hybrid applications which are composed of both VMs and containers. So sometimes we see applications which have like LDAP or database as VMs, and then containers for the application piece. And they want to be able to run those applications, those hybrid applications, through the same platform. And the list can continue and be long and long because those are all valid challenges. So what are the actual answers to that? How do we make virtualizations and containers really coexist within the enterprise? And for that, we have three major solutions. The first one is to continue to keep VMs and containers separate. And this is inefficient and risky. You have different hardware, as I mentioned, different teams, set of policies, and so on. The other one is to bring container into VMs. So you deploy VMs, and then you have those VMs running as Kubernetes nodes, and then you deploy containers on top of those VMs. That's also a solution. But this is a nested environment, and it's hard and complex to troubleshoot. It often requires proprietary solutions to make it happen. The last one is the opposite, is to actually bring VMs on top of existing Kubernetes infrastructure. This is a more sustainable approach, especially if Kubernetes is the future of your infrastructure. So Kubernetes has demonstrated the ability to provide a highly reliable, scalable, and extensible platform. And for this third option, the solution that can make this happen is named KubeVirt. And what is KubeVirt? So for KubeVirt is actually an add-on of Kubernetes. It's a virtual machine management add-on, which enables Kubernetes to deploy, provision, manage, and control virtual machines on the same infrastructure as the containers. It was initially created by Red Hat in 2017, and it's a cloud-native computing foundation project, incubating project since 2019. The underlying hypervisor that is used is KVM, and KubeVirt enables KVM-based virtual machines to be managed as pods in Kubernetes. Because virtual machines run as pods in Kubernetes, they benefit from the same declarative model, the same Kubernetes landscape in terms of CSI and CSI, CNI and CSI, so the cloud-native container networking integration, also the storage integration, all the storage options, all the built-in features for HA, for role-based access controls, and so on. It also benefits from all the Kubernetes ecosystems for monitoring, login solutions, security, you name it. But it also comes with some challenges. And KubeVirt is open source. You can go now or just after this webinar. Please stay with us. You can just go and download, install it today. But the manual installation can be very time consuming, and you may face challenges as it all depends on your environment. And you need to ensure compatibility with all the required components. So to start, you need first a running Kubernetes cluster on which you install the KubeVirt operator, then the CRD for KubeVirt, and the various components. And you need to do that for every single cluster where you want to run VMs. And one more thing, basic installation of KubeVirt allows you to run standard virtual machines, very simple, but to have advanced feature for virtualization, such as live migration, dynamic balancing of VMs across nodes, snapshot, cloning, advanced networking, and so on, you need additional components, such as the snapshot controller, Multus, CDI, and various others. So that's one big drawback of KubeVirt. The other one is the challenge of bare metal. Although it's technically possible to run KubeVirt on top of clone native instance or on top of other VMs, it's called software emulation. It has a cost in terms of performances. So really, it makes a lot of sense to run KubeVirt on the top of a bare metal Kubernetes, on top of a bare metal Kubernetes cluster. And that traditionally has not been easy. Standing up a bare metal server or a fleet of bare metal servers, deploy the OS, configure the OS, deploy Kubernetes and manage Kubernetes on top of it, and then add KubeVirt on top of it. So this can be challenging. The last one is day two operations. So with regard to day two, KubeVirt leaves the users with a lot of manual heavy lifting to be done. If we take a couple of examples, it doesn't come with a UI by default. You have some open source projects that can add a UI on top of it, but that's one additional component that you have to manage. By default, it's all command line or API, which is really not a big deal for platform teams that are really used to operate Kubernetes that way, but it may be a challenging gap for any virtualization admin. An operation just like starting, stopping a VM requires a CLI or an API call. And it's the same to live migrate a VM, to do a clone, a snapshot, and I will show you that in a moment in a demo. So if you're running at scale, so performing all those operations daily across many clusters that you have to manage and maintain, the effort is really considerable. And I will jump now to a quick demo. So I will share a different screen. Hold on. Yes, so I have a demo here. So I have a running Kubernetes cluster with KubeVirt installed. So I have a few nodes that are running, still running. And also I have a few manifest files to deploy my VMs. So a manifest file, I can just show you VM02. It's just a manifest definition of the VM. So I have a VM that I want to create, and it's called Webinar VM2. It has 2 cores, 2 gig of RAM. It also takes an Ubuntu 22 container disk, so it will install Ubuntu 22 and then do a cloud init for a specific thing. So if I apply that manifest file, vm02.yaml, it will create my VM on top of Kubernetes. So the VM here is creating. I will also create the VM03. So now if I go and check the VM object in my Kubernetes cluster, I can check and confirm that the VM are creating and starting. So they are already running because I already had the image downloaded into that Kubernetes cluster, so it was very fast. So I can observe, now I can manage those VMs. So for example, by default, I ask the VM to be running, but if I want to power it off, I can either edit directly the manifest like this, and I can just say that it should not be running. So I will ask KubeVirt to not run that VM. So you see that the VM now is stopping. But yeah, it's not a nice UI such as you can be used to with KVM or with vSphere. You can also completely exit this, and you can do a snapshot. So a snapshot from a VM, it's also a manifest file. So you can just edit that manifest and apply the manifest to snapshot the VM. So I want a snapshot on the VM, which is called Webinar VM1. And if I apply that snapshot, I can observe that the snapshot is creating and that I can restore it, but also, again, using CLI or API. So I have something called a virtual machine snapshot. And I see that the snapshot that I just created, so 20 seconds ago, is here and it's live. And I can see exactly what the snapshot is, when it was created, which object it refers to, and so on. Okay. One more thing is that there is another command line option, which is called virtctl or virtctl for others that can also use to manage VM. So it's virtctl, and I can do, for example, start the machine that I just powered off a minute ago. And I will just do start webinar, and the VM is starting. And I can use the same command line, the same binary to see the console, for example. So I can do virtctl console, not this one, console webinar, and then I connect to the console, and that's the actual console of the VM that is running. So the VM is booting now, going through cloud init. So that's the console of the VM. So I'm exiting the console. So now you see that that's KubeVirt. So it allows me to really manage my VMs. And I didn't show exactly how to install it because it was like some effort and because I know already how KubeVirt is working. But it took some time to install the operator, the CRD, to make everything work so that I can be able to do a snapshot. Now we have a different solution for that. So if I go back to my slides for a minute. Okay. So we have a new capability that was GA'd last week with Palette 4.0. So VMO, or Virtual Machine Orchestrator. So it's a feature that builds on top of Palette, our management platform for Kubernetes. And VMO adds the ability to deploy and manage virtual machines on top of existing Kubernetes clusters, or on top of Kubernetes clusters that are deployed by Palette. So VMO is based on KubeVirt, but it doesn't have the same challenge because we packaged VMO, we packaged KubeVirt with all the additional components that are required. And we made sure and tested that all those components can interact together. And this allows you to run VMs at scale and provide you a single platform to run VMs and containers on bare metal clusters. And really, VMO is for organizations that have committed to Kubernetes as part of their application modernization journey. And also for organizations that have already invested in Kubernetes skills, tools, those will benefit from that platform that can manage both of workloads. If you have some VMs that need to be refactored, it's also good because you can have that solution. So you can have the legacy VMs running side by side with containers while you do the refactoring process, which is usually long. In terms of feature, I don't have the complete list, but those are the main ones. That's the most compelling one, that the ones that the people are usually looking for. So first, and which is not represented on that slide, is that the VMO is available as an add-on profile. So it means that you have it as a pack that is available out of the box, and you can create an add-on profile for your clusters. And that add-on profile can be applied to all your clusters that are relevant, which means that you don't need to go and install manually or cluster by cluster that capability, that virtualization capability. If you create a profile and you apply it to, I don't know, 10 clusters, to a fleet of clusters, it will automatically deploy and take your cluster to the desired state with KubeVirt and all the associated components installed and configured so that you can run VMs. Now, in terms of management, so on the left, you have the management. So obviously you have API and CLI, just like KubeVirt has. We also have a Terraform provider that can help you to manage your clusters, but also VM resources. So you can just deploy VMs with the Terraform provider. We also have a user-friendly console that I will demonstrate in a minute to manage both VMs and containers at the same time. On the right side of the slide, you have all the features that are relevant to the VM themselves. So starting from the bottom, you have features that concerns the availability of the VM. So HA, so when a node has an issue or has experiencing some hardware issues, the VMs will automatically be restarted on a different node. Live migration, that's similar to vMotion for vSphere and for other platforms, where you can seamlessly warm migrate a VM, so without shutting it down from one physical node to a different node. Auto balancing of VMs, that's the equivalent of DRS at VMware. So we balance automatically VMs based on the actual consumption on the node. Node maintenance, so if you need to do like some hardware maintenance on a node, change some disks, change some memory stick, you can just put, we have it in the UI, you can just click turn on maintenance mode, and it will drain and code on the node, which means that it will seamless evacuate VMs using live migration to different nodes from the same cluster. And this allows scheduling capability on that node. You have all the node selections, affinity, anti-affinity rules, you name it. For VM themselves, if we go a bit up, we provide out-of-the-box templates, but you can also create your own templates, obviously. You can do cloning, snapshots, VM backups and restore. You can access the console via the GUI. You can do hot plug of CPU, of the NICs, and so on. We also developed a CLI tool that allows you to migrate, import your VMs from vSphere directly into Palette in the VMO cluster. And the same CLI can be used to import OVA also and transform the OVA in something that is meaningful so that you can deploy from those. So the AVA will be basically transformed into a template, and then you can deploy from that template in VMO. Now, before jumping to another demo, I will just see if I have the answer to the first poll. So the first poll was if you're familiar, how experienced you are with virtualization. So completely new to virtualization, we had no one that answered that. Approximately 20-25% are familiar with the concept. More than half of you have used virtualization in some projects. And experienced open source virtualization, KVM, 25% of you. Okay. And the second poll was, how familiar are you with KubeVirt? Not familiar at all, 0. And then approximately half of you have been using KubeVirt in the past, and half of you are using KubeVirt now. So I will just share my different screen again and jump to a different demo. Okay, so now for that demo, because obviously as it's with Palette. So this is Palette. This is our Kubernetes management platform, which allows you to deploy, manage, do all day-to operations for your Kubernetes clusters, whether they are running on-prem or on public clouds or at edges on your edge locations. So first, to install the VMO, I need to define a profile. So to define a profile, I can just add a cluster profile. I will just call it webinar VMO. It's an add-on. So it's an add-on to an existing cluster. And I can just add a new pack. I can either use the filter, or I can just, I know that it's in system app. And I just have that short tile. And you have some out-of-the-box configurations. You have pack versions that you can validate. And then based on that, you can just do confirm and create. So if you have, so that layer, that profile can be added to an existing Kubernetes cluster. And so KubeVirt and CDI, Multus, snapshot controller, descheduler, and all the components that we have included in VMO will be automatically deployed and configured accordingly so that the complete virtualization ecosystem works well. So for the sake of the demo and the time of the webinar, I already have a cluster that is running. So it's running on bare metal using canonical mass. We have a KAPI provider, so cluster API provider for canonical mass. I have a few nodes that are running. So one control plane, 5 worker nodes, and you can notice a virtual machine tab at the top. And this is running in a lab, so it's not production, so it's not showing the exact expectations in terms of UI performance. So you can create your virtual machines in namespaces. So by default, I have created a webinar namespace here, where I can create a new VM. So the namespace is here, but I can change namespace and create different VMs. So I have a webinar 1 VM that is running and where I can do a few actions. I can do power action, start, stop, pause, migrate, and so on. But I can also create a new VM with the wizard. So I have 2 templates in my environments. Obviously, you can have a lot more Windows templates, Linux templates, everything that you want. So I will call that one webinar 2. I will assign 4 gig of RAM. Split TDO of this is okay, and I will start automatically the VM after creation. I want also to define a static IP in the DHCP, so I can do, I know that this, I think this IP is free, /18, and then I know that the gateway is this one. I can change the cloud init, and then I can continue, and then I will create the VM. While the VM is creating, I will show you a few other things in the meantime. So I have a default namespace, for example, where I already have a VM running. I can check this VM is running. I can check the console. So it's a VNC or an SSH console that you can see. So I can log in here if I want. I think that Ubuntu, when I fat fingered, I was able to fat finger the user as usual. Ubuntu and then Spectro. And here it's like, it's the console of the VM, which means that it's similar to if I would be connected with a physical screen to a physical server. I have various tabs also that allows me to add network interfaces dynamically, either layer 2 or directly masquerade network interfaces. I can also add disks of various sizes. I can do snapshots. I can do also cloning. So I will come back to my webinar just to do those on. So the webinar 2 now is starting and it's running. So the VM that I just created based on my template is starting. It's started now. In terms of nodes, those are the nodes of the clusters. So I mentioned that we have maintenance mode. So if you select one node, you can see like the status of the node, but you can also check the hamburger menu and do turn on maintenance mode, which means that the node will be drained. So VMs running on that node will automatically live migrate to a different node of the pool. And the node will be cordoned so that no additional VMs will be able to be scheduled on that node while you do the maintenance. Once you're done, you just do the similar step and do turn off maintenance mode, and you can resume normal operations. If I come back to my VMs, I see that both VMs are running on bare metal AZ1 126, but I can actually trigger live migration, which is similar to a vMotion, just by doing migrate node to node. and I want to migrate this one to a different node. So in a moment, you will see that the node where the VM is scheduled will be different. So we can also go here, and it's you see that it's actually migrating right now. So this is done with no interruption of the actual applications of the VMs. And just like for vMotion, you have a single blip in the network. So you see that the VM has been live migrated to node 130 now. Finally, I can also add show snapshots. So I can take a snapshot of the disks while the VM is running, or if the VM is powered off. I have I'm aware of the warning. And I can take a snapshot, and the snapshot is just a point in time that you can come back again while you're doing. It's useful. It's not to be used with backups. I know that a lot of people are using those for backups. Those are not backups. It's useful when you do like some software upgrades and you want to do a point in time. If you want to do some forensics, you want to do a point in time and then clone from the snapshot, and so on and so on. So that's only so much I can show in a short demo in a webinar, but you get the point. I will just finish with a couple of slides, and I will see if there are any questions. Let me just go back here. Okay. So in terms of unique advantages, we have seen that KubeVirt really is a solution, but it also comes with some challenges. And Palette, the product that we, Spectro Cloud, develop, really with VMO brings KubeVirt further and allows you to have a more efficient way to manage VMs at large scale. It's a cost-effective solution because you can run side-by-side VMs and containers on the same clusters. It's provided as a capability at no additional cost. And it's really consistency of management. I haven't shown you, but we have complete airbag support. So you can define permissions, roles for your VM admins. You can define them based on namespaces, on clusters, on specific VMs, and so on. And so VMs and containers are both first-class citizens. It allows you to benefit from the rich ecosystem that Palette offers. So we have 50 plus out-of-the-box integrations with the major components of the CNCF landscape, whether it's for monitoring, logging, storage, networking, service mesh, Multus, etc., etc. So to conclude, really, if I want to really emphasize something, so VMs are here to stay. Again, VMs are here to stay. And they are here to stay even if cloud native applications have an exponential growth. We need to find a way to manage VMs and containers at scale in the same platform. And KubeVirt can be that answer. But KubeVirt is not a complete solution by itself. Also, it's managed at the cluster level, while VMO offers to manage it for many clusters. KubeVirt also has a steep learning curve, and that's why VMO is a perfect solution to manage both VMs and containers in a single platform. In terms of next steps, and that's my last slide, I encourage you to read the 3 actions, actually. So I wrote a blog post. You can scan the QR code, or you can just access the bit.ly URL. To explain more KubeVirt and VMO and what I just went through in 30 minutes. You can also get started with Palette, and we have completely documented the VMO feature in our doc site. It explains everything from the concept of the pack and how you add the profile to your existing clusters, how you create a template, performances, and so on. Now, let me check the questions. Feel free to ask any questions. I will just check. I see one. Is there any way to decide on which Kubernetes nodes the VM can run? Yes, that's a good question. So Kubernetes will, just like for pods, Kubernetes will decide on which node it's best to run a specific VM. But you can also manually enforce that using labels and node affinity and anti-affinity rules, just to decide on which node a specific VM is running. You can also separate VMs or make VMs run together with those rules. Also, additionally, with one of the components, the descheduler is maintaining a balance inside the cluster, which means that it will automatically move and migrate a VM if one node is experiencing a high load, and it will move some VMs out of that node. Any other question? Otherwise, you can also reach out to any Spectro Cloud employee or directly to me via social medias or directly if you have my contacts. Well, if that's it, I can also encourage you to join our community Slack channel where you can just get help and just discuss with other users. Just go to spectrocloud.com/Slack and you can just register. Okay, if that's it, well, that concludes this webinar that I was happy to prepare and present. I hope it was useful. And don't hesitate, don't be a stranger, as we say. Okay, thank you. Bye-bye.